All right, so let's take a look at some other clues that mass spectroscopy gives us. Remember that our overall goal here is to identify the structure slash formula of our compound, right? And so the main thing we pull from mass spectroscopy is the overall molecular mass of the compound, which is obviously very useful in determining what the compound is. But there are some other good pieces of information we can pull out from mass spec. And one of the most useful one is the presence of a chlorine or a bromine. So let's see how we see chlorine and bromine through the use of mass spec. And the reason that chlorine and bromine are special is because they're different than a lot of the other elements that we see. Most other elements have one dominant isotope. Even carbon's a little bit weird in that there's a whole 1% that's a different isotope. Most other elements that we see, there's one dominant isotope, and then the other isotopes make up a fraction of a percent of the remainder. Whereas chlorine and bromine are a little bit different. So chlorine, we have, if you look at the molar mass of chlorine, it's 35.45 grams per mole. And so remember, here we round to the ones place. So what do you count chlorine as? Well, you have to think about what isotopes it has. And so chlorine has two main isotopes, chlorine 35, which makes up approximately 75% of all chlorine atoms, and then chlorine 37, which makes up approximately 25% of all chlorine atoms. And so you can see if you take the weighted average there, you'll get about 35 and a half, right? And so because we have this kind of 3-to-1 ratio, right? This is essentially a 3-to-1 ratio here. We should see that in our peaks, and our two peaks should be two mass units different from one another. And so what we should see in our mass spectra is an M plus peak, our molecular ion peak, and then another peak that's an M plus 2 peak. It should be approximately 1/3 in size if the chlorine is present. And so let's take a look at this. Here we've got 2-chloropropane. So we've got this molecule right over here. And so let's take a look at what it has, right? You notice these are the biggest peaks over here, and we have one over here at 73 grams per mole. And then another one that's 2 away, right, at 75 grams per mole, right? And you can see they have this approximately 3-to-1 ratio. And so this is indicative of a chlorine, right? So on this 73 grams per mole, that's your chloropropane with a chlorine that's equal to 35 grams per mole, or a chlorine 35. And then the below is with a chlorine 37. So if you see these two peaks, and a molecular ion peak, and then a molecular +2 ion peak, that are approximately 1 to 1/3 in size, you know you have a chlorine. And bromine's overall pretty similar, right? It's also weird in that it has two dominant isotopes. So for bromine, we've got bromine 79, which makes up roughly 51%. And then we've got bromine 81, which is about 49%, right? And so if you're thinking about your mass spec, you should have two approximately same size peaks, one your molecular ion peak, one your M+2 ion peak. And so here we have the same compound as before. Now we just switched out the bromine with, or the chlorine with a bromine, and let's check it out. And so if you look down here, right, you see two approximately evenly sized peaks with a 2 molecular mass difference. And this peak over here is at 122. And then this one over here is at 124. And so that you know that you have a bromine there.